So, what do you want to do now? Let's slip into something more virtual. I like the sound of that. Honey, I'm home! You'll never guess who I ran into at the— What the f is this? It's not what you think. Are you cheating on me with another processor? Please, I can explain. What, am I not hot enough for you? No. Actually, you're kind of too hot for me. Plus, you're not the most punctual. You're not helping. Why? Hey guys, how are you all doing? Really? That's just great. You know, I'm doing pretty great today too because Apple announced they are moving away from Intel and instead they're switching to ARM-based custom Apple Silicon for future Macs, which means we'll get better performance, better power management, and a bunch of other features that we'll talk about later today. Now, Apple Silicon is an SoC, which is System on a Chip. So basically, traditional components in a computer architecture are all crammed into a single chip. That's a high-level overview. This is a big transition in Mac history, and with a big transition comes some uncertainty. So I know there's some questions out there that need answering, and I'm going to do my best to address those today. So sit back and let me drop some knowledge on your A55. Rest assured, Apple has been through transitions before, so they are prepared. Apple switched from 68K processors to PowerPC and released the first PowerPC Mac in 1994. Then they rewrote the Mac OS and released Mac OS X in 2001. Then they transitioned from PowerPC Macs to Intel Macs and released the first MacBook Pro and early 2006 iMac. They've also worked with ARM chips dating back to the Newton. All previous iPhones used ARM-based processors, and so did all iPads. In fact, the A-series chips we're familiar with today debuted with the first iPad in 2010. So what's one more transition, right? I think we'll be okay. But there are a few factors to consider, and we will go over those very soon, but first, let's take a look at the timeline for this transition. Tim Cook announced that the Apple Silicon transition will be completed in 2 years, and the first Apple Silicon Mac will be released before the end of 2020. He also said more Intel Macs will be released, but we don't have a solid timeline on how long Apple plans to release Intel machines. Additionally, Intel versions of macOS will still be released for, quote, years to come. So why bother? Why is Apple doing this Apple Silicon transition? What's the point? The simple point is they just want to make better products, but that's kind of a vague answer. A key component to making that goal happen is to have higher performance, but more importantly, higher performance per watt. Which means, theoretically, with an Apple chip, you can compute just as much information as with an Intel system, but you would be using less power in doing so, which gives you plenty of room to crank up that power and boost your performance significantly. This is similar to the main reason as to why Apple ditched PowerPC processors back in the day. They released the iMac with the G3, G4, and G5 processors. They did the same thing with the Power Mac line. But when you look at their notebooks, you'll see a G3 and a G4, but not a G5. Why did Apple not release a PowerBook G5? Well, performance per watt. They could not match the thermal conditions and battery life that they wanted, among probably many other factors we don't even know of, with the G5 processor. When they looked at Intel, they could tell that that roadmap would let them build the products they wanted to build. And that's kind of what we're doing today now with Intel to Apple Silicon. But honestly, performance per watt is just the beginning. Apple Silicon will offer unique features to the Mac. Apple Silicon will help make Macs more secure. Apple's been using their custom silicon for security features in iOS devices for years. In fact, Apple has implemented some of these security features in select Macs with their custom T1 and T2 chips, which work alongside the Intel processor. With Apple Silicon, there's no need for a separate T2 chip. It's all built into one SoC, which will allow for more security features that I'm not even aware of yet. Okay, so we have faster performance, better power management, and better security features. But what else is there? Well, for starters, the Neural Engine is now coming to the Mac, which will accelerate machine learning tasks. Also, a high-performance GPU architecture will accelerate pro apps and games, which is combined with a unified memory architecture which allows the GPU to access memory insanely fast. In short, this chip can do a lot of stuff. And even better, Apple won't be tied down to Intel's product release schedule anymore, nor will they be restricted by the thermal output of those chips. It's all in Apple's control. To me, the most exciting part of this transition is the scalability. We've seen the A-series chips come so far in 10 years. This is the first iPad with an A4 in it. This is nowhere near as fast as what we have 10 years later in the iPad Pro. The iPad Pro's GPU is about 1,000 times faster than what's in here. In just 10 years, 1,000 times the performance. So imagine what we can do inside a Mac, which has a much larger enclosure. Now, I've had quite a few people ask me, why is Apple using a mobile architecture for their Macs? And to that, I simply say they're not. Yes, ARM works great for mobile, but it scales. The Fugaku supercomputer. It's all ARM-based, yet it clocked in at 415 petaflops. So for some quick math, that's over 400 quadrillion floating point operations per second, all on ARM-based processors. So I think the Mac will be fine. So now the big question, will my software work? What about app compatibility? Well, ARM64 is the instruction set for Apple Silicon. That's what it's based on. And the Intel Macs are based on x86-64. They're different. Those Intel Mac apps won't understand ARM64 out of box. Simply, they won't work. But Apple has a plan to help fix that. There's 2 tiers of Intel compatibility, Rosetta 2 and Universal 2. Rosetta 2 provides compatibility for Intel Mac apps as is, without developer intervention. This won't work for everything, but it should be okay in most cases. 2 restrictions are you cannot translate kernel extensions or virtual machine software which virtualizes x86-64 computer platforms, like Windows. That aside, Rosetta achieves this compatibility by translating the application upon installation via macOS package and App Store installs. Applications that don't use these installation methods are translated on first launch. I meant launch. Can someone bring me a sandwich? The second tier is Universal 2. Universal apps contain code for Apple Silicon and Intel processors, and macOS automatically knows which code to run. For many apps, all the developer has to do to make a universal application is open up their Xcode project in the new version of Xcode and build. That will work in many cases, but there will be instances where a few days of work has to be done. But after that, the developer can now release a universal application, which will run natively on Apple Silicon, but also on Intel Macs. Apple already has their productivity apps, their pro apps, and their built-in system apps all running on Apple Silicon, and they're working closely with Microsoft and Adobe to make sure Office and Creative Cloud also runs on Apple Silicon. Apple also launched a QuickStart program, and when you apply to it, one of the things you could potentially get, if you're accepted, is a prototype Mac Mini. It looks like a Mac Mini, but it has an A12Z Bionic chip in it. Yes, the same chip that's in the new iPad Pro. And this is pretty nice because the Mac Mini is a lot smaller than the giant 40-pound cheese grater tower that Apple gave you for the Intel transition. So what about Hackintoshes? I get that question a lot. Well, for now, you don't really have to worry because Apple is still going to be releasing Intel versions of macOS. macOS Big Sur signifies the beginning of this shift to Apple Silicon, but it still runs on Intel. And future versions, not sure how many future versions, but I would say at least one future version will also run on Intel too. So you have a little bit of time to figure out how to Hackintosh an exclusive Apple Silicon-based macOS if you wish. What about Boot Camp and Windows? So on a current Intel Mac, you can run the Boot Camp Assistant, and boom, you can install Windows on your Mac. Heck, you can even install Windows on some of these really old PowerPC Macs if you have the DOS card, which this one does have installed. It's really cool. Anyway, that's great and all, but you cannot do this on Apple Silicon Macs. In short, the traditional Windows x86-64 software will not run. Now, Microsoft does have Windows on ARM, yes, but that's only for PC makers. They don't just sell that at the store. You can't just buy that off the shelf. Plus, it's not going to run all the programs you'd probably want to run anyway because it's ARM-based. Maybe Apple and Microsoft can work out an agreement where you can buy a copy of Windows on ARM for your Apple Silicon Mac if you really need it. So that future is a little bit uncertain, but in short, unfortunately, x86-64 Windows will not run on Apple Silicon Macs. However, we might see some future virtualization software that can run Windows. Yes, you can't run Windows inside a virtualization program under Rosetta, but that's just Rosetta. There could be a future, more native solution that could come down the pike, and it might work. But we don't know that just yet. Just another note, since Apple Silicon is a common platform for iOS, iPadOS, and macOS going forward, you can actually run iOS apps and iPadOS apps natively without modification on your Mac. As for boot options, you can install multiple versions of Apple Silicon compatible macOS. You can boot internally, you can boot externally as well, and you can even install versions of macOS that Apple stopped signing. You can even set startup volumes to boot with full security mode or reduced security mode. Target disk mode is also being deprecated, and it's being replaced with a feature called Mac sharing mode, which essentially turns your Mac into an SMB volume that you can access files on over the network. I'm not really sure how this is different from just enabling SMB sharing inside the system, but perhaps it's useful because you can use it without the system being in a functioning bootable state. I'm not sure about all the details in regards to this because during the presentation in the WWDC session, they really just glossed over this feature, so to be continued on that one. Okay, so I know that was a lot, but I do want to know your thoughts about this whole transition, so feel free to leave a comment down below, and if you have any questions about this, feel free to ask, and I will do my best to answer. Also, Renee Ritchie and Jonathan Morrison also did good videos about this topic, so feel free to check those out as well. And if you liked the video, you know what to do. Thanks for sticking with me, catch the Krazy, and pass it on.